Yeah.
Okay. Solving radical equations is what we're looking at today. So we're going to look at the first few examples and then assign some problems for you to practice. Looking on page 452, we're going to look at example 1. It starts out like this. It gives you an equation that has a radical. Nathan would say that's a square root symbol. Right? So that's exactly what that means. A radical expression means that you have some kind of expression. In this case, it's going to be a cube root with stuff underneath it. And we're asking you, this is another strategy in finding the value for a variable. How are we going to figure out what x is so that this is a true statement? So that this stuff on this side equals 3. You've got to get x by itself. Okay? So one of the strategies that I've taught to you before, if you had a square root, what would you do to get rid of a square root, to undo that? How do you get rid of a square root?
Power of 2.
Yeah, you square it, right? You have a power of 2. Sounds like. Well, this isn't a square root, this is a cube root. So if you've got the radical all by itself, you don't have anything outside of it that's added or multiplied, you want to first do that. You want to isolate the radical expression. In this case, it's already isolated. Chris?
Wouldn't you move the radical to a square to a cube and keep the one side and the other also?
That's right. So Chris is saying, since the radical is already by itself, there's nothing being multiplied out front, there's nothing being added to it, it's not being divided, it's not being subtracted outside, you have that radical expression all by itself on one side of the equation. You just want to get rid of that radical simple. It's a cube root. What would undo, what would unravel a cube root? A cube. Chris and Jeff say it's a cubic. So what I would do on this side is cube the left side. Now you learned back in middle school with algebra, if you do anything on one side, you've got to do it to the other, right? Here's the Stevenson rule. You can do anything to anything, as long as you do it to everything. Algebraically, you're going to be okay. So if I cube on the left side, I have to cube on the right side of the equal sign. Well, cubing a cube root just sort of unravels it, erases the 2, so that all you're left with is what's underneath that radical symbol. On the right-hand side, we're going to cube that, so of course we would get the number 27. Now it looks like a pre-algebra equation, right? Very simple thing to step through. You just got to get x by itself, and I just do those steps to do that. Very quick. Very quick. Okay? Example 1. Are you good? Example 2. Now Cheyenne would say, in her absence I'll say it for her, the examples are always so stinking easy. But the problems in practice are so hard. Well, let's see. Let's look at example number 3 and see what we can do to step through that. Jump into example 3. There you have an equation that doesn't look like a radical equation, and that's what we've titled this lesson to be. But is it? Is it a radical equation?
Yeah.
Why, Sam?
It's a radical equation because there's a power as well as a cube.
As a root, right? We have a fractional or a rational exponent. 2 is a power, and 3 is a what? A root. So this is a radical equation. So the steps that they give us to solving this is, again, I want to get, here I had it written in radical form and it was all by itself. Now I want to get that radical expression by itself. So it's being multiplied by a 4. So the first thing you want to do is get rid of that. So that all you have is the radical expression. You only have the term or the part, the factor that's being cube rooted in this case. Okay, but it's written in rational form. It's x to the 2/3. How are we going to get x by itself? How are we going to undo this stuff happening to it so that all I have is x by itself down here somewhere. Talk to me. Yeah.
Don't you go through the steps of cube root it and then you put like 2 extra x's into it?
Okay, so Sam's saying this divided by 3 means it's being cube rooted, right? How do you undo cube roots? You cube it, right? Now watch this. She's saying that if I did this, that's cubing it, right?
Yeah.
And if how do you multiply fractions? You can cross reduce, remember from grade school? Right? I can kill those 3's off, 3 divided by 3.
Or if you prefer, you can convert it if you're a big fan of conversion like myself.
Certainly could, except when I'm afraid
What?
that if you did convert it to, I'm thinking maybe a decimal or something.
No, not decimal at all. No, I mean convert it to a radical equation and then solve it.
Absolutely. If Jeff's more comfortable in seeing it written in this form, taking a few extra steps, absolutely you can do that. You still get the same answer. Now that gets rid of the 3 that we started with, but I still have what? The power of 2. But you've learned, Sam's going to want to tell us, how do we get rid of squaring? We square root.
So you could just multiply by 3 seconds, right?
And I'm doing it in steps so that you can see what we're doing. Ron is saying, well, we could do it in 1 step just by multiplying by 3 halves instead of just multiplying by 3. So again, we can square root this, and Jeff would say, oh, well, I would have used the radical expression. Is that okay? Absolutely. You know, or you could have divided by 2 in the exponent, which again is square rooted. Either way you feel more comfortable, it's absolutely fine. I've got an x squared, I'm going to square root it to get rid of it, to undo it. Well, if I do that on the left, I've got to do it on the right. So the square root of 9 is what?
3.
You're half right.
Thus,
Wait.
plus or minus.
There you go.
Yeah.
Again, I'm not sure if they're wanting the principal root. Yeah.
But wouldn't it be different because first you took the 3rd root of it, so wouldn't you have to take the 3rd root of 9?
No, when we took, we had the 3rd root here and we, oh, we forgot to cube. Very good. Thank you very much.
You can take the
Yeah, I'm
3rd root of
confused.
3.
And we missed that step. When I cubed on the left, we forgot to cube on the right. Thank you for catching that. Great environment. So I've got a cube on the right as well. Or take that 9 to the 3rd power. Let's just leave it like that a minute. I know it's a bigger number. Let's just leave it like that just for a second. And again, if I want to square root this, that isolates the x. But then what have I got to do on the right-hand side? Square root it, which again, if you wanted to write it square root of 9 to the 3rd, that's absolutely fine. Or you could write it in rational form, 9 to the what? 3 halves power. Now that's a number. It's not a variable array, so you can do those things. We've taught you how to simplify using your calculator. You can take the square root of 9, which would be 3, and then cube that.
27.
And you end up with
27.
the answer that you simplified. Or you could have cubed the 9, got this huge number, and then try it, and then take the square root of that. Or you can use your geographic calculator and go 9 raised to the power, caret key, parentheses, 3 halves, and get the same answer. So those are things that we're going to ask you to practice. To solve equations, sentences, that involve radicals. Can you follow those examples? Do some practice. Thank you to the YouTube